Hi there, this is Math 8, Unit 4, Lesson 2, called Keeping the Equation Balanced today. And we're going to figure out unknown weights on balanced hangers. And so they begin looking at a picture of some socks. And here you have two socks, and you notice that they seem to be keeping the hanger nice and level there, unless I do that with the paper. Now it's not. But let's keep it level. Over here, we notice that this sock seems to be a little heavier, so it's pulling this one down, which causes the hanger to be not balanced any longer, right? So you kind of have to wonder what's happening here with this sock to make it heavier than that one, because it does look to be skinnier than that one. So maybe someone put some, I don't know, put some beans in the socks or something. I don't know. Who knows? But it made the sock heavier, and now it's hanging down there. Maybe it's wet, you know, stepped in a puddle on the way to school. Who knows? But there it is. Hanger's imbalanced, and boy, that's just not going to work, is it? So that was what you did first of all. Let's take a look then at activity number 2, which was called hanging blocks. All right. Hanging blocks is right here. And with the hanging blocks activity, what we were looking at was, we said we had a picture of some hanging blocks that show that we have some squares and triangles. Okay, and it says this picture represents a hanger that is balanced because the weight on each side is the same. So even though you have different types of things on the two sides, it's balanced because it just happens to be equal or proportional there, right? No, so that's right, equal. Don't say proportional. Equal. This equals that, and so it's gonna stay balanced. It's like two matching socks. It's okay. They might look different, but the weight is gonna be the same. It says that Elena takes 2 triangles off the left side. So she takes 1, 2 off the left side, okay, and 3 triangles off the right side. 1, 2, 3. Will the hanger still be in balance, or will it tip to one side? Well, because we're just taking off triangles, if you take 2 off of this one and 3 off of that one, we have a problem, don't we? We didn't take it off evenly, right? If it was just 2 and 2, we would say, oh, sure, that's going to be balanced still, because it's a 1 for 1, right? It's like adding 1 to both sides of the equation, or subtracting 2 from both sides. But here I'm subtracting 2, and here I'm subtracting 3, okay? So we would say it's definitely not balanced, because we didn't take things away the right way. And the other thing we'd say is it's going to tip, in this case here, to the left. It's going to tip to the left because why? We took more away. This is lighter now. This one's heavier because it has more than that side does. It's going to tip left. So be careful about how you think about that one there for how it works. Now it says, if a triangle weighs 1 gram, how much does a square weigh? It's a great question. Okay, so let's consider our square. We're going to call square x. Okay, just for now, call it x. So on this side here, I have 1, 2, 3 squares. 3 squares. Plus, I have a triangle, 1, 2. Now the triangles, it said, are equal to 1 gram, so I'm just going to call that 2. Right? I have 3 squares plus 1 gram for each of my triangles on the left side. And it's because it's a hanger thing, we're going to say it's balanced. Over here, I have 1 square. So we can write down 1 square if we wanted to. And we're going to add to that 1, 2, 3, 4, 5 triangles. So as an equation, this is what my hanger is showing me. I have 3 squares, 2 triangles on one side, and then 1 square and 5 triangles on the other side. By setting up this way, I can find out what the squares are going to be equal to. Here I said we're going to call squares x, and I wrote down s. I'm going to switch the s's to an x real quick. Alright, and now we can go ahead and solve for x. Alright, so I'm going to subtract 2 from both sides. That goes away. 5 minus 2 is 3. And I'm going to subtract 1x from over here, and 1x from both sides there. That goes away. So 3 minus 1 is 2x. So 2x is equal to 3. I can divide both sides by 2. To find out then that x is equal to 3 over 2. So what is the weight of 1 square? 1 square is equal to 3 over 2, or I could say it's equal to 1.5 grams, or I could say it's equal to 1.5 grams. Those are all acceptable answers because they're all the same value. Okay, so that's what we're doing there. Let's take a look at another one. It says a triangle weighs 3 grams and a circle weighs 6 grams. Alright, so a triangle is 3 and a circle is 6. Find the weight of a square in hanger A and the weight of a pentagon in hanger B. Okay, so here I'm looking for the square, and over here I'm looking for the pentagon. All right, cool. Well, let's see what I know. For triangle, for A, we know that the triangle is 3. So I'm going to just put numbers here. This is 3. A circle is 6, so it's a 6 and a 6. And here's my X. I don't know what the square is. And another 6 there. Over here, I have an X and an X and an X and an X and a 6 and an X. Okay? So that's what I have there, looking at what I know. Triangle and circle values, and I don't know squares. I can turn this into an equation there, right? To figure out what that's going to be. So let's take a look here. I know that, for example, the weight of a square, okay, we have, on this side, we have 6, 6, 6, and 3. That adds up to be 21. Okay? So on triangle A, or for hanger A, I have 21 plus, in my case here, 1x. Okay? This is for A, sorry, A is going to be equal to the other side, which is 6 plus 1, 2, 3, 4, 5x. Okay? So now I want to get the x by itself. So I'm going to subtract an x, subtract an x. So I have 4x over here. And subtract a 6, and I have 15 over here. So 15 equals 4x. Divide both sides by 4. So that x equals 4 or 15 over 4, which is also 3 3/4, or 3.75. That's the value of a square. So a square is 3.75 for hanger A. Now in hanger B, over here, we have circles are again 6 and 6, and here's a 6, and a triangle is a 3 and a 3, right? So think of it this way. I have, on the one side, I have 12 plus 2 pentagons equals 12 plus, right, 12, add those up, plus 2 pentagons. On hanger B, I have an issue because I can't tell what it's going to be equal to, can I? Right? The pentagon could be equal to 1, and that works. It could be equal to 100, and that works. And the reason is because the equations are exactly the same, aren't they? Right? If I subtract 12 from this side, and both sides, that goes away, and that goes away. Now I have 2p equals 2p. Well, that's not going to work very well, is it? If I divide both sides by 2, then p equals p, which means that it could be any value because it's going to work no matter what. So we would say for B, in terms of the weight of a pentagon, for the pentagon weight, we would say it's not, we can't determine, not determined. Okay? We can't determine what it's going to be. We don't know. So write an equation represent each hanger. It's the next one, number 2, which we've kind of already done. So for hanger A, we have 3 plus 6, oh, sorry, 3 plus 18. Right, we have triangles plus our circles plus our 1 square equals our circle plus our 5 squares there. So we've already kind of done this up above for A there. And for B, we would say that what we have is we have 12 plus 2 pentagons equals 6 for triangles plus 6 for circles plus 2 pentagons. Okay, this is my triangle there and my circles. This is my circle. This right here is my circle. And these are my triangles, and that's my circle. All right, so that's how my equations could look there. But with the hangers, you can tell right away, are things balanced or are they not? Let's take a look at the Are You Ready for More on the next page. It says, what is the weight of a square on this hanger if a triangle weighs 3 grams? So a triangle is 3. So it's a 3, and a 3, a 3, and a 3, and a 3. Okay, now because they're equal, one thing I can do is I can say, well, let's get rid of things that are balanced, right? So this triangle here can cancel out that one there, and I still have a balanced triangle. This triangle here can cancel that one there, and I still have a balanced triangle, right? This square could cancel out that square there, and I still have a balanced, I keep saying triangle, balanced hanger, supposedly. But what do you notice? I have a problem, don't I? How is it that these could cancel each other out, and I'm still left with that and nothing over here? Is this possible? Can you actually do that? We would say, I don't think that's possible, right? Now look at it this way. What if we do it like we did before? Here I have 3 triangles, right? So 3, 6, 9, that's my 9 for my triangles, plus 1 square, we'll call that x. And we set that equal to 3 plus 3 is 6, plus 1x there. And we try to solve that. If I try to solve that, here's what happens. Let's subtract 6, okay? Right, so I have a negative 3, sorry, I have a positive 3 equals, subtract an x, subtract a, oh, this is 2x, sorry, 2x. Subtract 2x, so I have 3 is equal to negative x. Well, this is going to be a problem, right? To get the negative x to go away, I multiply both sides by negative 1. So I have negative 3 equals x. Awesome. So the weight of a square is negative 3. Can you have a negative weight? I'm thinking probably not. Probably not going to work there, right? So this is not possible. All right, kind of cool. So in summary, if we have equal weights on the ends of a hanger, then the hanger will be in balance. Okay? If there's more weight on one side than the other, the hanger will tilt to the heavier side. We can think of a balanced hanger as a metaphor for an equation. An equation says that the expressions on each side have equal value. And that's what we're getting to today. Okay? Just like the hanger has to be equal to be balanced, okay? An equation says the same thing. The hanger is a nice way of saying it's going to be equal. And so when it doesn't work out the right way, it's just not going to be good. Okay, let's take a look at tonight's homework. All right, tonight's homework, here we go. Which of the changes would keep the hanger in balance? Select all that apply. All right, so we have our hanger here, okay? What I noticed first of all is they both have a triangle on them, right? Which means I can kind of forget about the triangle a little bit. And what I noticed then is that one square is the same weight as 2 circles, isn't it? That's why it's in balance. We're going to say it's in balance because it says it's in balance. So 1 square equals 2 circles. Okay, so keep that in mind. If we add 2 circles on the left and a square on the right, so we add 2 circles here and a square there, will that work? Well, we said a square is the same as 2 circles, so that would work. That's going to stay in balance, no problem. That's going to work, okay? Adding 2 triangles to each side. If I'm doing it to each side, that's going to stay balanced. That would work, right? Triangle, 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 triangle. Great, it's going to work. Adding, what's the next one here? 2 circles on the right and a square on the left. So circle, circle, square. Well, we know that 1 square equals 2 circles, so that would work as well. Sounds great. Adding a circle on the left and a square on the right. That won't work, right? Why not? Because 1 circle is only half of that weight, so this is going to be heavier. We're going to drop down that way. Too heavy to the right. Add a triangle on the left and a square on the right. Triangle there. Well, this one here, I don't actually know, right? I don't know if that would work or not. And the reason I don't know if that would work or not is I don't know the weight of a triangle. Could a triangle be the same weight as a square? It could be, but I'm not sure. So I'm going to say no for now because I don't know. I can't determine the weight of a triangle compared to the weight of a square. So we're going to say no for that one. Let's look at number 2. Here is a balanced hanger diagram. Each triangle weighs 2.5 pounds. So we have 2.5, 2.5, 2.5. Each circle weighs 3 pounds. 3, 3, 3, 3, and 3. And x represents the weight of a square. X, 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 X. Select all the equations that represent the hanger. All right, so on this side over here, I have 1, 2, 3, 4 x's. 4 x's. I have 2.5 and 2.5, which is a total of 5 for the triangles, right? And for the squares, a circle, sorry, I have 6 circles, and that equals 2 more x's right there, and plus a 2.5 for the triangle, plus a 1, 2, 3, 9 for the circle. So that's my basic equation. I'm going to write that down and take a look at what I have here. Over here I have 1, 2, 3, 4 x's. That matches so far. Plus 11. 5 plus 6 is 11. Check. And then plus I have an x. 1 x right there. I need 2. That's not going to work. That's my problem. We would say no for letter A. Oops. Let's look at B. B says 2x equals 0.5. Oh man, that one did some work. I have to do some work there? Sure. Let's do some work here. Actually, let's come back to B. We'll come back to it. Okay. Here we have 4x plus 5 plus 6, that matches, equals 2x plus 2.5 plus 9. I have 9 that says 6. That's not going to work there. Sorry. All right. We have 2x plus 2.5 equals 3. That doesn't match what I have. Let's come back to that one. 4x. 4x plus 2.5 plus 2.5. Well, that's what I had for the triangle, right? That made 5. Plus 3 and 3, that made 6. That's looking good so far. 2x, and then a 2.5, and then 1, 2, 3 3s, that made my 9. That one matches there. So we're okay with E. E is working great. Now we're left to figuring out these ones, which seem to be more simplified, aren't they? So let's group some stuff together. So this becomes 4x plus 11. Write that down. 4x plus 11 equals 2x plus 11 plus 2.5 is, 9 plus 2.5 is 11.5. All right. Now, we're looking better here. Let's subtract 2x from this side and subtract 2x from this side. And I have 2x plus 11 equals 11.5. Okay? So I'm going to subtract 11 from this side, subtract 11, and I have 2x equals 0.5. Well, that matches that one just fine. Looks great. Awesome. Now what about this one right here? This one, 2x plus 2.5 equals 3. You gotta kind of go, where did that come from? That's a great question. Here's where this came from. Okay, ready? What if we go back and get rid of things that match? Ready? So those match, we eliminate. Those match, eliminate. Any more squares? Nope. Here's a triangle, so we eliminate those triangles. Any more triangles? Nope. Circles. Sure, here's a circle. Here's a circle. So what am I left with over here? I'm left with 2 x's. Matches that. A 2.5 matches that. And a 3 matches that. So that's where D came from. If you did some elimination of your shapes, then you just get the D right there. Cool, that's it. Number 3, what is the weight of a square if a triangle weighs 4 grams? We're going to look at the next picture here. Triangle is 4 grams. Triangle is 4 grams, so triangle equals 4. So we have a 4 here, a 4 there, a 4 there, a 4 there. And what is the weight of a square? Well, let's figure it out. We have 4 plus, call these x, 2x equals 4, 8, 12. Plus 1x. Okay, so we can solve it this way. We can subtract x, and we're left with x equals minus 4, 8. Now, is another way to do that? Sure there is. Ready? Let's eliminate what matches. So there's triangles. That goes away. We eliminate the square there. And what do we have left? 1 square equals 2 triangles. 2 triangles sum up to be 8. So you can look at it in the picture and solve that as well. All right, number 4. Andre came up with the following puzzle. I am 3 years younger than my brother, and I am 2 years older than my sister. My mom's age is 1 less than 3 times my brother's age. When you add all our ages, you get 87. That's my age. What are our ages? Okay, so Andre had apparently a really long car ride to Grandma's house to celebrate maybe Thanksgiving. All right, so he had some time to think about some crazy math problems in the car because maybe the DVD player ran out and was scratched, couldn't watch the movie, I don't know. All right, no Wi-Fi, so he's making math problems. What a good idea, Andre. Try to solve the puzzle. Well, okay. Andre is 3 years, here's Andre. Andre is 3 years younger than his brother. So let's call his brother B. So brother minus 3 is Andre's age. Way to go. I am 2 years older than my sister. So Andre is going to be his sister's age plus 2. Way to go, Andre. Okay. And my mom's age is 1 less than 3 times my brother's age. So mom's age is 3 times my brother's age minus 1. Way to go. Now, when you add them up, you get 87. Wow. Here's a problem I have so far. Remember last time we tried to substitute some stuff around for Andre and brother and stuff, right? But I had an A equals and an A equals and M equals. I don't have letters that quite work out the same, do I? So I need to rewrite these here. I know that Andre is Andre. We'll keep him as an A. By himself, whatever. Now, for the brother, I can put the brother here as a variable by saying the brother is actually equal to, let's add 3 to both sides. The brother is equal to Andre plus 3. Right? By moving this over there, we can say what the B is equal to. The sister, similarly, is going to be equal to Andre minus 2. If I move the 2 over there, the sister is equal to Andre minus 2. The mom is fine because it's an M variable. M equals 3B minus 1. So we have Andre, the brother, the sister, and the mom. So I have all 4 variables here that I need, right? You with me so far? So, in terms of what's happening here, we have Andre, look at this one here, is X. We can call that our A value. That's our A. We use A. The brother, A plus 3. That matches right there. The sister, A minus 2. And the mom, which is 3 times, now they did 3 times X plus 3. Huh. That's interesting. 3 times X plus 3. Okay, my mom's age is 1 less than 3 times my brother's age. 3 times my brother's age. Oh, got it. Well, the brother's age is, remember the B is X plus 3, so we have that goes right there. That's the B part. And the 3 is there, and the minus 1 is there. So we're plugging everything in between there. Explain the meaning of the variables for each one. Okay. In this case here, X is going to be equal to Andre's age. Can you write the equation in fewer terms? Sure we can. Okay, let's do it then. Let's do this here. We have X plus 3 plus X minus 2 plus 3 times X plus 3 minus 1 equals 87. Okay, so all I've done so far, have I solved the problem yet? I haven't done it yet. I just kind of put up my variables to figure out what it's talking about. And I noticed that in letter B, Jada's written it with X's instead of A's, and we're in the same spot. Okay? So we're looking good. Now, if to solve this here, let's get these things out of the parentheses. So we have the X is fine, plus X plus 3, plus, this becomes X minus 2. Over here we distribute. 3 times X is 3X. 3 times 3 is 9. Minus 1 equals 87. So we're going to combine some things together. We have 1, 2, 3, 4, 5, 6 X's. Those are all our X's. 1, 2, 3, 4, 5, 6 X's. And we have 3 minus 2 is 1. Plus 9 is 10. Minus 1 is 9. So we have plus 9 equals 87. We subtract 9 from both sides. So 6X equals 87 minus 9 is 78. We divide both sides by 6. And X equals 13. So Andre's age is going to be 13, and we can find out everybody else's age by plugging that in, right? So Andre is going to be 13. The brother is Andre's age plus 3, so that would be 13 plus 3, which is 16. For the sister, she's Andre's age minus 2, so that's going to be 11. And for the mom, we're going to say that's going to be, in this case here, right? It's the brother's, 3 times the brother's age. Well, the brother is 16, so 16 times 3 is 18, carry the 1, 48, minus 1. So she's going to be 47. All right, does that all add up to 87? Well, let's see, 7 plus 1, 6, and 3, so that's going to be 17. Carry the 1, and 1, 2, 3, 4, 87 in total, and we are good to go. All right, and I think, is that it? Oh no, there's one more. Yep, one more problem, sorry. So these two lines are parallel, write an equation for each. So let's take a look at number 5. And these two lines are parallel. Let's write an equation for each of these lines. This is a review from lesson 8. So here we go. Write an equation. All right, well, let's take a point. Let's take a look. We'll call this one A, and we'll call this B. Okay, so here is a point right there. Right there, looking great. All right, and I have a point on that spot there. Do I have any more points over here? There's a point right there. So I like to find some points here. If I find some points, it might help me out with kind of that slope and what's happening with that slope moving from one to the other, right? So there's a point there, and I have a point here. So let's take a look first of all at A. We can see that it is going up 1, 2, 3, 4, right? So going up 4, and we're going over 1, 2, 3, 4, 5. So in terms of my slope, I'm going up 4 and over 5 is my slope based upon that picture there. I can check that out by looking at this one here and seeing that I go 1, 2, 3, 4 up and over 1, 2, 3, 4, 5, and I have point to point. So I know my slope is 4/5, right? I also have a point here, by the way, as well. Okay, so I'm definitely going up 4 and over 5. That's my slope. Because they're parallel, I know they both have the same slope. And that's going to be true as well. So now in terms of how do I want to write this equation out, okay, there's a couple ways of doing this here. I could put it in what we call the point slope form, which was that y equals the slope times x plus that y-intercept where it crossed the y-axis. That's one way of doing it there. Or I could use the one of the points and plug that in there. Now to do the point thing, I have to know what the slope's going to be, which in this case here is 4/5. How could I find that slope out? If I didn't know this part here, the way you could get that is by taking a couple points, right? I could say that in this case here I have a point here at 0, 0, 0, 0, and over here I have a point at 5, 4. So to find the slope out, remember I can do the y2 minus the y1, 4 minus 0, over x2 minus x1. So 4 minus 0 is 4, 5 minus 0 is 5, and there's my slope. Okay, and I can do that with any 2 points to find the slope. That's going to work there. So now to put that back into an equation, let's look at A for example, I have a point 5, 4. So I can do y minus 4, that's my y point, over x minus 5, that's my x point, is equal to my slope. So that works for A. Okay, and for B, again I find a point, and I could use the point that's right here, the 0.32, or I could even pick a little nicer point if I wanted to, it doesn't matter. I could use this one, which is at 4, 0, right there. That's a point as well. Again, lots of points to choose from, and I could say y minus 0 over x minus 4 equals 4/5, and that could be an equation for that one there. Again, I could get rid of the 0, so it's just y over x minus 4. If I wanted to put it into the point slope form here, no, the y-intercept form, sorry, I could take a look at, in this case, the first one, A. A, as we can see, our slope is still 4/5, right? That's our slope, 4/5 x, and we're crossing the y-axis at 0, so it's plus 0. Okay, over here on this one, we know it's also 4/5 of the slope. And where does it cross that at? It crosses at negative, in this case here, negative 3.2, because that's our y value when x equals 0. So that would work as well. So all of these work. Okay, you have 2 different ways of writing it out for A and 2 for B. And that's it for the day. Have a great one. We'll see you next time.